Good afternoon, dear colleagues and guests. Today is the 18th of May, 2022. It's 3 p.m. Moscow time. Let me declare open a session of the Dissertation Council for the defense of thesis of Nekrasova, Diana Olegovna, for the degree of candidate of Geology and Mineralogy, specialty 164, Mineralogy, Crystallography, Geochemistry, Geochemical methods of mineral exploration, on the theme Novel Sulfate Inorganic Materials with Transition Metals, Crystal Chemistry and Properties. By the order of Academic Secretary of St. Petersburg University, Gniodov Alexander, dated the 2nd of March 2022, order number 1781/1, me, Britwin Sergei Nikolaevich, Doctor of Geology and Mineralogy, Professor of the Department of Crystallography of St. Petersburg University, was appointed Chairman of this Dissertation Council. Members of the Dissertation Council were appointed with the same order. Let me introduce them to you. They are Brusnitsin Alexey Ilyich, Doctor of Geology and Mineralogy, Professor of the Mineralogy Department of St. Petersburg University. Belogub Elena Vitalyevna, Doctor of Geology and Mineralogy, Associate Professor, Deputy Director for Scientific Affairs, South Urals Federal Research Center for Mineralogy and Geoecology of Ural Branch of the Russian Academy of Sciences. Besides, in the remote access mode, the session is attended by Galuskin Evgeny Vadimovich, Doctor of Geology and Mineralogy, Professor, University of Silesia in Katowice, Poland. Evgeny Vadimovich, can you see and hear us? Yes, all is well, thank you. The answer is yes. Astrid Holzheide, Doctor, Professor, Christian Albert, University of Kiel, Germany. Astrid, can you hear us? Please say yes.
Yes, I can.
So all is well. All 5 council members are present. The degree applicant is also present, Nekrasova Diana Olegovna. The thesis was written at St. Petersburg University and the University of Lille, France, under the supervision of Doctor of Mineralogy, Crystallography and Geochemistry, Sidra Oleg Yohanovich, who is now present, as well as PhD in Chemistry, Associate Professor of Solid State Chemistry Department of Lille University in France, Marie Calmont, who's attending in the remote access mode. Can you hear us now? Can you hear us?
Yes, thank you, that's fine.
Окей, все нормально, слышен.
In order to perform the quality of communication, dear colleagues working in the remote access mode, please switch off your mobile phones, not to be disturbed, but please remember to turn them on when you're given the floor. But we'll remind you, don't worry. Let me also inform you that our session is being recorded and broadcast at St. Petersburg University website. The speeches are being simultaneously translated from Russian into English or from English into Russian. At the moment, during the council session, an email is displayed to which all the listeners may send questions to the applicant or give their opinion regarding the content of the thesis and the applicant's presentation, and thus take part in the scientific discussion. These questions shall be forwarded to me by our technical support department, and I shall present them during the discussion. Questions should be related strictly only to the applicant's speech and the content of the thesis. At that, it's necessary to indicate the name, title, and place of employment of the author of the question. Questions that are not related to the scientific discussion, text of the thesis, and anonymous questions should not be presented. In accordance with the order of awarding at St. Petersburg University the degree of Candidate of Sciences and Doctor of Sciences approved by the local regulations of St. Petersburg University, hereinafter referred to as the Order, a session of the Dissertation Council shall be considered competent if at least 2/3 of the appointed council members are present, but not less than 4 persons. Our council, as you can see, consists of 5 persons. All 5 are present, including 2 council members working in the remote access mode. Audio and visual contact has been established with them. Thus, we have the quorum. I invite the Dissertation Council Activity Support Department officer, the curator of today's defense, to draw up the attendance list. Well, dear colleagues, we have another procedure requirement. In order to comply with the regulations set by the Ministry of Education, Science of Russian Federation, let me establish the following procedure of today's session with approximate duration of 2 hours. First, summary report of the chairman on the applicant and the documents submitted by the applicant and their compliance with the applicable regulations. Answers to possible questions. That should take not more than 5 minutes. Second, summary report of the applicant outlining the key points of her research. We agreed that the presentation will take 20 minutes. So that's like 5. We decided to give her 5 extra minutes. 3, questions to the applicant strictly regarding her presentation, no more than 2 minutes per 1 question. Answers of the applicant, no more than 5 minutes for all the answers. 5, presentation of external reviews, if any. We have 1 external review at the moment. 6, speeches of all the council members in turn with their assessment of the thesis and the applicant's speech, as well as questions and suggestions to the applicant. Approximately that should take like 10 minutes per each speaker. Speech of the council chairman, also 10 minutes. Item 8, answers of the applicant to questions and remarks made by the council members, no more than 20 minutes. Item 9, not the last one, is speeches of the attendees with summaries of their opinions and specific suggestions to the applicant regarding the topic of his study, not more than 2 minutes. At that, all the speakers are requested to introduce themselves, given their full name, title, degree, if any, and place of employment. 10, presentation of questions to the applicant received during the discussion and live broadcast of the council session at the university website. Please note that written questions, the presentation of which takes over 2 minutes, unfortunately shall not be presented. 11, answers of the applicant, no more than 2 minutes per 1 question. 12, speech of the thesis supervisors, no more than 3 minutes for each speaker. Discussion of the council members before open voting of the defense results. But for that period, sound shall be switched off. 14. Open individual voting. The chairman shall count the votes, and the results shall be recorded in the minutes of the meeting. 15. Making decision on awarding and not awarding the degree. And finally, closing remarks of the applicant. No more than 2 minutes. Dear colleagues, dear council members, do you have any general questions or objections? Nobody has any questions? Okay, then let's start the session. Please remember to switch off your mobile phones. Dear colleagues, working in the remote access mode, please do not switch your phones, because we may want to reach you in case of emergency, so that we could reach you in case of emergency. Let's start the session. Summary report of the chairman. Nekrasova Olegovna wrote her thesis for the degree of candidate of geology and mineralogy, specialty 164, mineralogy, crystallography, geochemistry, and geochemical methods of mineral exploration, on the topic novel sulfate inorganic minerals with transition metals, crystal chemistry and properties. Was accepted for defense by the order of Academic Secretary of St. Petersburg University on the 4th of February 2022. Order number 78718/1. The number of publications which set forth the key results of the thesis according to the enclosed list is 6. And in journals indexed in the scientific databases, Web of Science and Scopus, 6 publications. Other documents, according to the information I received from the curator, comply with the applicable requirements and are kept in the applicant's attestation file. Copies are also available from the Dissertation Council Activities Support Department officer, who is now present. Before I give the floor to the applicant, I have a question to the council members. Dear council members, do you have any general questions to the applicant? And is it necessary to review the entire list of documents submitted by the applicant? Obviously no, there are no questions. Then let's proceed to the applicant's presentation. Diana Olegovna, the floor is yours.
In English, and I will start. First of all, I would like to start the present of the structure of my talk. As expected, I will start with introduction, then I will go to the new mineral species gregenite, and then I will go to the big part of my work, synthetic analog of fumarolic mineral species, and finish with summary and perspectives. So, why it's so interesting to study sulfate in organic minerals? Sulfate minerals attract considerable attention due to their wide distribution in nature, in active volcanic fumaroles. But this kind of minerals are unstable under ambient conditions, and this fact made it difficult to investigate. The Telbachik volcano is a unique place where we found more than 400 different minerals. Also, they are interesting due to the wide variety of structure architecture, and the sulfate with alkali and transitional metals show interesting magnetic and electrochemical properties. The unusual magnetic properties provided by divalent kappa cation. Kappa is 3D transitional metal with quantum nature of S equal half. But sometimes kappa could behave like superspin, where S equal 1. This kind of material related to the physics of low-dimensional quantum magnetism. My work is the result between two scientific groups, Lille University, France, and St. Petersburg State University, Russia. Our laboratories have differences, but we have one common goal: to obtain new material, to study properties, especially magnetic properties, and of course share with each other knowledge and experiences. The main idea of my work we can call minerals as advanced materials. But I want to point your attention that I've done a full cycle of research, from study of fumarolic minerals, including field work, to structure characterization of these minerals, prediction of the properties and synthesis conditions, synthesis of new fumarolic minerals inspired material and novel compounds, structure characterization of these synthetic compounds, and study physical and physical-chemical properties. On this slide, you can see method and major task. It was the development of geosphere rules for the synthesis, preparation of polycrystalline samples, crystal chemical analysis, and measurements of physical properties. I work with synthesis with this system: alkali metal plus transitional metal plus sulfates anion. First of all, I work with this kind of elements, but not all of them provide me good results. What does it mean, good results for me? Good results when we have new crystal structure, new synthetic compounds. And eventually I work only with these kind of elements which provide me new synthetic compounds, majority of them related to the fumarolic minerals. I've done a lot of synthesis, more than 300. I used different methods for the techniques, but eventually I used only two: solid-state techniques in air for polycrystalline sample and solid-state techniques in vacuum to grow big single crystals. The work with sulfates is quite challenging task. Let's consider why. First of all, they're unstable in air and easily dehydrate in air. Secondly, they're very soluble. A third one, they have low thermal stability and usually decompose above 600 degrees. As I told before, one of their goals was field work. And one of the results of this field work was a new mineral species, glicinite. The mineral glicinite was named after Professor Arkady Eduardovich Glikin. The glicinite is monoclinic. Crystal structure have 3 M sites. Each M site occupied by copper and zinc, in the majority case by zinc. But we don't know exactly in each position how we have copper and zinc. We could know just qualitatively by microscope analysis. The crystal structure consists from ionocentric chain. This chain is surrounded by sulfate group. I want to point your attention that anhydrous zinc sulfate minerals are very rare species in volcanic escalations. The very common associated mineral with glicinite is ilmenite. Ilmenite has in mineral admixture of the zinc. It's why I also prepare magnesium members and zinc members, and also for glicinite I prepare synthetic analogs. All of the unicell parameters of the synthetic phase you can see on this slide. To establish the temperature of crystallization, it should be taken into account the ratio of the alkali and transitional metals. To know exactly ratio, it could be only by X-ray diffraction analysis in the case of magnesium. Due to that we could achieve only pure sample for magnesium members, we study some of the properties: infrared spectroscopy, X-ray diffraction analysis, and high temperature X-ray diffraction analysis. Crystal structure of ilmenite, you can see on this slide. Crystal structure has 3 independent M sites. In the case of magnesium member, M site, M1, fully, most of all, occupied by copper cation, and you can see this John Taylor distortion. M2 site occupied by magnesium in the majority case, in minority by copper, and M3 sites occupied by magnesium in the majority. In the case of the zinc members, again, like in glicinite, we could not establish by X-ray method how much we have copper and zinc in each position, only qualitatively total amount by microscope analysis. The ilmenite was approved in 2015, and this started the beginning of new big family. I want to point that no before my work was known this ratio of alkali and transitional sulfate ratio. I've done cesium nickel, cesium cobalt, rubidium cobalt, and rubidium nickel sulfates. The first crystal structure is cesium nickel one. The crystal structure is layered in interlayered space occupied by zinc cations. What is interesting, this crystal structure consists from two M sites occupied by nickel. Nickel 2 and nickel 2 share edges through each other, and nickel 2 and nickel 1 share corners. Next crystal structure is cesium cobalt sulfate. Crystal structure have 3 M sides. Cobalt 3 and cobalt 1 form dimeric units, while cobalt 1 like isolated. The cobalt polyhedra connects through sulfates group and form three-dimensional framework. Next crystal structure, rubidium cobalt and rubidium nickel, more similar. Crystal structure have 2 M sides. M sides form trimeric units. These trimeric units also link through sulfase group and form cavities. Cavities surrounded, occupied by cesium atoms. The lowest ratio for alkali and transitional metals was first of all found for saracenoid mineral. Saracenoid is anhydrous form of granite. As you could see on the slide, granite was known a long time ago, while saracenoid known only 7 years ago. I've done both of these synthetic compounds. Crystal structure of granite and saracenoid are different. To prepare samples, I use 2 different techniques. For prepare single crystal, I use solid state techniques under vacuum, and to prepare polycrystalline sample, I use Zoll-Gel method. For saracenoid, was done full of this investigation. On this slide, you can see copper packing of the saracenoid crystal structure. Crystal structure have 4 symmetrical independent copper 2+ sides. Because of the close distance between copper, it was very interesting to measure magnetic properties. The dependence of the magnetic susceptibility from the temperature is linear, and it means that our compounds is paramagnetic in high temperature region, but below 50 K we could see the slope of the Curie-Weiss law, and it means that our compounds start to behave like antiferromagnets. It could be the reason of these dimeric units of the copper. Also, it was very interesting to study electrochemical properties due to the question of could sodium migrate in the crystal structure. Our experiments show the crystal structure electrochemical active, but it was very difficult to extract and insert sodium on lithium atoms. It could be due to the very difficulties to oxidation from copper 2+ into copper 3+, as it was previously described. The copper 2+ and copper 3+ redox potential has been predicted to provide a high operating voltage in rechargeable battery system, but these phenomena are still hard for understanding and requires additional study. On this slide, you can see evolution of the structure of saracenoid morphotropic series from sodium to cesium, and it was very interesting to note that sodium and cesium could form their own structure type, while potassium and rubidium more isostructural. The next one, morphotropic series related to the langbeinite mineral. I've done rubidium and cesium members. On this slide, you can see crystal structure of cesium cobalt sulfate. What is interesting that the connections between cobalt polyhedra with sulfate polyhedra is through ages. This kind of connectivity was also described in chlorothianide. Next morphotropic series was provided for cryptocalcite type compounds, pipite, and chlorothianide. Also, rubidium in nature is very rare, and I done all this full of the morphotropic series. Rubidium and cesium has a big ionic radius, is big differences, and for sodium we could not achieve these compounds as a question of the future. The majority case, I have no one, usually 3-5 phases according to the synthesis. And for example, when I've done ethyl-minized synthesis, the impurity was sodium copper sulfates. It's synthetic puninite. Puninite, fidetavite, and efflorine as minerals was described in Fumarolo-Tolbacic volcano, and according to efflorine, to Vesuvius volcano. I've done all of these synthetic compounds, plus rubidium and cesium members. Crystal structure consists from ionosynthetic dimeric units. These units are surrounded by sulfate groups. In neutralized space, you can see alkali metals. I put on the frame rubidium and cesium members because they have insertion of the neutral CuO units. What is interesting, because also we have close distance between copper cation, it was also interesting to study magnetical properties. And dependence of the magnetic susceptibility from the temperature is also linear in high temperature region. Our system behaves like S equal half paramagnets, but below 100 K it starts to behave more difficult, like superspin S equal 1. We have different connection between copper 1 and copper 1 is ferromagnets, and other connection is antiferromagnetics. What was interesting that Fujiyama already studied for potassium compounds, and it belonged to the physics of Haldane chains. But our study was achieved that this is not related to the Haldane chains physics, it's more related to the square lattice model, and it was confirmed by inelastic neutron scattering and DFT calculations. On this slide, you can see crystal structure along A-axis, and as I told before, kappa 6 hexamers behave as 6 individual spin with S equal half in high temperature region and as macro spin in low temperature region. What will be if we will insert neutron CuO units? In the case of the rubidium, we have randomly occupied by 7/10 this kind of units, and in the case of the cesium, to go to the full occupied cluster, we should go to the supercell lattice with doubled B parameters. The question of the prepare pure polycrystalline sample was very difficult in this case. I tried a lot of synthesis, and I also mentioned if I work with stoichiometry ratio, I could achieve the good result. I don't have pure polycrystalline sample. If I add more CuO, I have it. And it's why we also done for cesium compound different kind of investigation with additional CuO units. And what is the differences between magnetic properties for cesium and rubidium members? In general, the cesium members also behave like superspin, as you can see, the Curie-Weiss law. But according to the heat capacity anomaly, we could not see this should be here lambda type anomaly for cesium and for rubidium, but we don't have it. It could be the reason of this insertion of CuO units. And I want to go to summary and perspective. First, a new fumarolic mineral species, glycinite, was studied. It is the first anhydrous zinc sulfate minerals known to date. Glycinite crystal structure is based on chain units. 19 new synthetic compounds, 7 new structure types were obtained and structurally characterized. All new compounds were obtained in anhydrous system by the solid-state synthesis and non-gas transport reaction. All of the obtained new compounds have fumarolic mineral analogs structurally related to the mineral species. The minerals and synthetic compounds of several anhydrous alkali copper sulfate series demonstrate vivid examples of morphotropism with the formation of structure types dependent on the size of the cation residing in the cavities of their framework. Cesium copper sulfate and cesium cobalt sulfate demonstrate the rare H-sharing MO5 polyhedra SO4 tetrahedra. Fourth, a single-phase polycrystalline cerunchenite analog can be obtained by Zolgel method. Cerunchenite synthetic compounds is completely hydrated in air and transformed into cronchite. A low amount of lithium and sodium can be interacted into the structure. Sodium copper sulfate is paramagnetic in high temperature region, but below 50 K, antiferromagnetic interactions appear. The structure principle employed for puninite series allow for the passage from 1D-like hexamers arranged in diplets chain to longer tetradecamers after insertion of neutral species. The compositional and topological changes are driven by variation of the internal chemical pressure and cell volume that depend on the alkali size. It's striking that the theme of the ferromagnetic and antiferromagnetic exchanges effective in the individual subunits return to S equal 1 magnetic clusters in both cases, themselves interacting in 2D layer rather than in 1D chain due to the specific magnetic path. The chemistry of anhydrous sulfate provides rare and specific opportunities for stabilized less common environments, for example CO or 7, for such magnetically active cations as copper, cobalt, and nickel. It's also possible that in more complex system mixed cations, for example copper 2+ and copper 2+, would order to provide new uncommon crystal structure and magnetic behavior. Investigation of certain binary and more complex sulfate systems are expected to shed more light into the crystal chemistry of magnetochemistry of these families. On this slide you can see a published article according to my thesis, and this slide shows your abstract. And I want to express my gratitude for the estimated help my supervisors Alex Sidra, Marie Calmont, and Olivier Montre. Thank you for your attention.
Спасибо. Уважаемые коллеги, мы
Dear colleagues, we listened to the presentation now. According to the procedure, I have a question for the council members. Do you have any questions regarding her presentation? She's just given outlining the key points, so short questions, no more than 2 minutes per each question. So that's not full presentation of your review. Alexey Ilyich Brusnitsyn has a question. Thank you. I will remain seated if you don't mind. My question is quite specific, and the second is a little bit more general. Could you please go to slide 11? Okay, maybe no. It's this one here. This one here. Yes. So it was this mineral interested me a lot, and I read its description in your work. So first, I know, for example, that there are silicates or titanite, cesium, kyanite, silicate with additional anion of oxygen. So you have sulfate, not oxide. Why do you put oxygen? You're breaking the formula writing, the rules of formula writing. Let me ask your question. Yes, indeed, according to the rule, it's necessary to put oxygen in the end, but let me note that today both variants are possible, and this variant is accepted by the new mineral, the commission on new minerals. So they made a mistake, honestly, because this is not a sulfate formula, it's an oxide formula from a point of crystal chemistry. So from the point, so oxygen is not included in the sulfate group. Okay, I understand. And I have another short question. So you are using, but your actual composition is different. And why have you chosen this composition? Both the chemistry, zinc 2, copper. Yes, indeed. In my report, I just am using zinc 3 here, but so we have of copper is close to 1, and it has its own position. In my work, if I remember, I use both zinc 2 copper and zinc 2 as simplified notation. So that was my short question. Now a more general question. Well, you've done so much work, you have many publications, you've synthesized many minerals. Could you, in 2-3 sentences, describe the key points of your study? You've done so much, so what are the key points? My case study is the study of physical properties. The idea that minerals as prototypes, no, that's ideology. No, of your work, how, having done so my conclusion, the main conclusion is that sulfates are very promising from the point of future use in electrical chemistry, for example, and that's why it's necessary to study them further, because this cluster is quite poorly studied compared with phosphates. I understand the answer, thank you. So are you satisfied? Yes, thank you. Dear colleagues, do we have more questions regarding questions for presentation? You have questions to the applicant, for the applicant? I see there are no questions. Then, dear colleagues, let us proceed to speeches of the Dissertation Council with their assessment of the thesis and the applicant's speech with questions and suggestions to the applicant, and presentation of external reviews, especially comments. We have, there's one thing, the applicant can answer each reviewer individually, or can take all the reviews at once and answer them together in the end. As far as I know, colleagues have lots of questions. So what should we do? I suggest, so we only have 5 reviews. So let's get personal answers. Do you mind that? Is that okay? So nobody has any objections to that. Then I suggest the applicant answers each reviewer individually, and so we have one external review published by Olivia Hernandez, Rennes 1, France. I won't read this review. It's available at the university website. The review is generally positive. It's got some minor remarks, mostly of technical nature, and the thesis looks very good, and by its quality and impact on chemical synthesis, it can be accepted as PhD thesis according to the results of the defense procedure. In that case, let's give the floor to the council members. I will invite them one by one, since all the reviews were published at the university website. There's no need to read all of it. You can just summarize the key points or maybe remarks and suggestions to the applicant. Do you, the council members, have any objections? If so, let's proceed to the presentation of reviews. With your permission, I will first give the floor to the council members present, and then we'll proceed to our colleagues working online. Elena Vitalyevna, could you please start? Okay. Can you hear me well? I won't dwell on. Can you hear me? Yes, I think so. I beg your pardon. I will read my review in Russian. The thesis generally makes a good impression. The author has done lots of work. It's dedicated to a relevant topic, though the practical significance to me is not obvious, because its possibility to synthesize these compounds, but implementation, the use of this potential still requires huge investment and experts. Scientific novelty is explained by the fact that the author has described new type of minerals, glycinite, and improved the synthesis methods and the methods of study where she obtained fairly good results. So I will not read all the critical remarks because some are specific and the applicant saw some of them. And in my opinion, the main drawback is with the work is that it is like a mosaic. The chapters are weakly related with each other. And, well, you can immediately see that natural minerals and synthetic compounds studied with the use of different methods. So that is illogical, and I don't know why this happened. From the text is not clear, while the spectrum electrospin resonation has been done only for some objects, but not all of them. When writing different sections of the thesis, the author uses different terms for structural elements, even in such familiar field as crystallography. Each chapter has an introduction and conclusion. The remarks, comments in methodology get repeated in each section. So you get a feeling that there's no general conclusion. On the one hand, the methodological part in chapter 2 is very detailed, but some important data has been omitted. And the number of experiments, their comparability, and just be sure, if we can get sure and be achieved, that the same results will be achieved. It would be good to include the names of laboratories where the tests were conducted, already in chapter 2. The terms are also dubbed, and so there's some fault with that. I have only one gross error. That's then when the author, the energy dispersion, they can be separated. Anybody will tell you that. Besides, as a model for zinc copper, pure metals were used, but though it's necessary to consider the matrix effect, and that's not exactly correct. So what standards were used for natrium, for sodium, calcium, rubidium, and cesium? Of course, the author used something. Some references, in my opinion, are incorrect, and which said that sulfates are unstable in air media. So this is not has been known for almost 200 years. It's not quite clear how the author interpreted thermograms and the results of thermogravimetrical analysis. This is very complex analysis, and its interpretation is connected with some difficulties, theoretical difficulties. In one case, recrystallization of new phases is connected with the endothermal in the effects, and in the other with exothermal. So maybe these points could be explained, or at least references should have been made, because interpretation of thermograms is not completely validated. Besides, the author has X-ray structural analysis conducted at various temperatures, but everything could be this validation could be more substantial. The author also used a method, a calculation method, to calculate the migration paths of base cations, but first she conducted such migration that no migration is possible. So first maybe the author should have counted first, and then should have counted before running these tests. So why is what's the reason for the use of this matrix for magnetic sulfates? This, of course, is a technically specific question of deciphering the. So there were no calculations, and finally, in my opinion, is critical in chapter 8, which deals with synthesis and physical properties of rubidium containing sulfates. There is quite a lot of information on the Kuril-Kamchatka volcanic ridge, and rubidium content is 13 ppm, and to speak that in this today it's possible to detect own rubidium phases. The author should have substantiated her model why such phases are. So this content is really very small. And as for the geophysical data in vulcanites, I beg your pardon, but this is typical for all magma minerals. So this part, the geochemical part, in this thesis, it looks strange and out of place, and you could have done without it. Or she should have paid more attention to explaining the models of rubidium concentration in her formula, with such considering such low concentrations. In general, the Russian part was created by back translation, so there are incorrect terms not used in Russian and some style errors because originally the thesis was written in English. I read it in Russian, that's why it jumped me in the eye, and then I switched to the English text and it was okay. Yet, despite my numerous comments, which are of technical nature, and considering the number of experiments, we might say that the thesis by Nekrasova on new sulfate inorganic compounds with transition metals, crystal chemistry and physical properties corresponds to the requirements set by the order on the 1st of September in 2016. The order number is the different order. The order for awarding academic degrees at St. Petersburg University, and the applicant Nekrasova Diana deserves awarding the degree of candidate of geological-mineralogical sciences, specialty 164 Mineralogy, Crystallography, Geochemistry and Geochemical methods. Articles 9 and 11 of the above-mentioned order has not been violated. No plagiarism has been detected in the thesis. Thank you. Thank you, Elena Vitalyevna. Please answer the questions. Thank you very much for your questions. First was about practical significance. Indeed, the full study of indeed requires additional experiments and involvement of other scientists and patent applications. So we have not done so, but maybe we will do so in near future. Next, then about the structure of the work. Yes, I agree, and apologize for my style, which was not very successful. Indeed, this chapter is a separate study within the general topic, and I confess it was difficult for me to link the chapters together, since each chapter is a small completed project which became the basis for 8 research papers. And why not all the studies were carried out with spectroscopic or electrochemical? These were from the point of structural properties, as you mentioned. For sarantinite, the so first we conducted an experiment, and then we found out why the experiment was not successful. But for Illuminati phase, we also conducted in the so first we started with calculations, and we decided that experiments will not be successful, because that was the purpose of our collaboration with another university. As for in the introduction, since because in the beginning of each chapter I try to give brief information on the because they can be different from the point of, and I agree that I should have created a more detailed chapter of literature overview. As for the agreement on page 11 of the Russian version, that repeatability will be registered for all syntheses. As for separation of copper and zinc into, so the peaks can be separated. I made a mistake in the text, so I beg your pardon. And to determine the ratio of copper and zinc, we used in our research, we used VDS, because the results, that way the results, more accurate results can be obtained. And so DTA, such recommendations we took into the, and I agree that this were not so good ethanol, but that's what these were samples or benchmarking samples that were available to us. Also, we have molybdenum to exclude molybdenum, because yeltenite is obtained. There's a contains molybdenum, and structurally they are very different. Why we haven't done produced other samples? Because biochemical analysis was conducted for glycemate and yeltenite phase. Other not required analysis. As for references to unstable sulfates in 1920s, yes, this is common, and I've given references to our works published since they talk about the minerals and chemical compounds, and indeed I should have indicated the original sources of this data. As for exothermal effects, and it happens so that this analysis is very complex, and we conducted it because we had to determine the crystallization temperature of the compound. I used it for a mixture of reagents, and as is obvious, not always, the phase is not always accompanied with the thermal effect. So these are our results. These were our results. Next. As for the element we used in the matrix, about that I speak about it in chapter 6, because it became a very important, and I used to determine the replica at subdomains, and I explained this in page 71 of the Russian version. As for the Russian version, yes, indeed, sometimes there's a word-by-word translation. I agree that it's not used in the Russian tradition, and the main text was because it was this joint program, but that does not diminish the fact that of course I had to edit the Russian text better. So I apologize for the typos. Thank you. Elena Vitalyna, are you satisfied? Yes, I am satisfied with the answers, and we can this. Alexei Ilyich, it's your turn now. Your remarks and your comments, please. Thank you. Dear colleagues, the procedure at our university is that each reviewer is an opponent. As an opponent, I try to look at the positive and negative aspects of the thesis. So that's it. So let's start with the good things, of course. Then Olegovna was very lucky to be a student and to work at two outstanding science centers, such as Crystallography department under the chairmanship of Professor Sidra, and at the University of Lille in France under Associate Professor Marie Calmont. So the studies were not wasted. Diana Olegovna can synthesize substances. She can decipher crystal structures on a wide range of various and complex minerals. So the work is obviously requires for some research skills, which she has certainly acquired. And as evidence of that, she published 6 articles in respected articles, where in 3 articles she's the main author, and she also made presentations at the Department of Crystallography, and also for me, so that's why the thesis indeed complies with the requirements, all the applicable requirements, and I think the claims quite justified. At the same time, I have a whole number of remarks, but I'd like to say that these remarks are not so much about the work and its essence, but about the style, the presentation of the material. I'd like to say that from the beginning, the text of today's speech were prepared much better than the Russian text of the thesis. The text of the Russian text leaves much to be desired in terms of editing. And I'd like to mention some points. So first of all, I agree with Elena Vitalyna that the thesis doesn't look one complete piece. It's like a collection of separate elements. I won't dwell on that. This was mentioned already. And so let's proceed. My second remark is connected with this structure. And as a reviewer, I was very upset. I was not, because I am convinced that clearly stated results indicate how much the applicant understands the work she has done and the role of the findings. And so this and the absence of such provisions actually diminishes the value of the entire work performed by the applicant without such scientific conclusion. So thesis is not about, so there should be some kind of a summary. Of course, the world won't stop, but I'd like to see some overall conclusion. And so I tried to ask you this question earlier, and unfortunately I'm not satisfied with your answer. So you can this answer can apply to any work at all. Next. I have some questions about the. I have to. So Crystallography department. I know at least. I've known for 30 years, and calling this field as novelty, I think, is very immodest. Second, when opening the new mineral, Diana Olegovna is only third in the main work was done by, so it's quite immodest to say that this scientific novelty. I have no doubt that scientific novelty is there, but I'm very upset that you didn't bother to state it. Also, I can understand why it's about the, so I couldn't understand that part on batteries, and so this is something, it's like it's out of place, it doesn't belong, and I don't know why it's there. I was very upset that in the list of references there is only 52. There's not only 75, and there's no single publication in Russian. And it's not that publications are not available. So the Tolbachik volcanoes in Russia, and your colleagues, they opened and making no reference of them, not mentioning them, appeared incorrect to me. And also, I was upset with the wording acknowledgements in introduction, which is for technical support. Period. Diana Olegovna, dear Diana Olegovna, you been educated. This is not technical support. And in the same introduction, you got to the French government and the French ambassador to Russia, but this has taken a whole paragraph, and for university only one line, so please do not upset me in the future. I hope that these remarks of mine you'll benefit from these remarks and use them in the future. But anyways, as the opponent, I'd like to say that this my remarks are about mostly concern the style, the presentation of the work, and the work on which certainly complies with the requirements. And according to the protocol, I have to read the obligatory part that new sulfate with transition methods, crystal chemistry and physical properties corresponds to the requirements set by the order dated the 9th of November 2021 on the order of awarding academic degrees at St. Petersburg University, and degree applicant Nekrasova Diana Olegovna deserves awarding the degree of candidate of geology and mineralogy, specialty 164, mineralogy, crystallography, geochemistry, geochemical methods. Articles 9 and 11 of the above mentioned order has not been violated. Thank you. Thank you, Alexei Ilyich. Diana Olegovna, thank you very much once again for your questions. About the structure of my work, I have answered already, and indeed it was hard for me to connect the parts. As for propositions to be defended, and well, as they indicate, I made conclusions in the work in the end, and in which I have conclusions in each chapter, but I have not put them in a separate list because this was not is not an obligatory part, and since my work is a joint project with the University of Lille, so I decided not to include them in the work. It was hard for me to comply with the regulations, and I could only, both in Russia and in France, and could only partly achieve that, and such propositions are not used in France. As for novelty, I agree that I should have written it in more detail in my case, and I have emphasized that the main idea was to use, but we've done a full cycle of works from mineral collection in fumaroles to synthesis and study of properties. And there is not so many examples, not so many teams of research where the full cycle of research is conducted for base minerals. And as for inserted fragments, I certainly agree. That was my initiative. I added these chapters to make it easier for the reader to understand. So they don't come from school textbooks. These come from scientific publications. I tried to translate into simple language and made S4 acknowledgements. Here I cannot agree, Alexei Ilyich, because in the second paragraph, I said that laboratory is very well, St. Petersburg University, University of Lille is very well organized, and I named all the people to whom I'm grateful. And in the end, so that was, of course, all the resource centers that supported me in my work. I certainly mentioned them, but my gratitude to the staff of resource centers comes first. Without them, nothing would happen. I think that's it. I think I have answered all the questions. Thank you, Alexei Ilyich. Do you have any other comments? No, I understood the answers. Now we have to invite. I have to give the floor to our colleagues, and I'd like to invite Dr. Holzheit. So please give your comments. Thank you. Can you hear us?
Yes, I can.
Thank you.
Thank you very much. And first, I would like to clarify that I do not know the candidate in person, and thus I'm only able to judge her written performance, her brilliant presentation, which she did today, and also the discussion part. And you know already how the thesis is structured. We heard some comments of the two colleagues regarding the structure of the thesis. I don't want to repeat this, but I really liked that you have those chapters and there are some kind of bracket by the introduction and by the conclusion chapter. And I just want to now mention 4 parts, which I would like then to have you as a comment on it. And in chapter 2, you are talking about the experimental part and methodology. And it's really good because you do some overview about the 6 used methods and also the determination of the chemical composition. You provide information about the calculations and also already a little bit about the new synthetic compounds. Sure, the synthesis you want to do, actually your goal are 2 goals. One is you want to synthesize new material to also later on think about those geo-inspired materials, so minerals as advanced materials, but also I would say to understand how those minerals forms in nature, meaning that this is now my comment. So a question is about more like the in-depth information regarding the really used methods for your synthesis. And I'm also an experimental petrologist, so I know that why we have to use the vacuum, why we have to use inert atmosphere, but this is not nature. So could you later on provide some comments regarding the conditions that actually prevailed in nature? So how are they different compared to those you use in the laboratory for the mineral formation, meaning what are the difference to the fumarolic formation, to the formation out of volcanic gases, which is a little bit missing in your written part. And then I was also a little bit surprised about 2 things. One is you are mentioning in chapter 5 the minerals and also the solid solutions and the pliconite, and you say that there are some impurities of sodium. So, but neither the copper 2+ nor the copper 1+ have similar ionic radii compared to the sodium, which is huge compared to the other. So I would like to know what this means related to the distortion of the crystal structure when you incorporate sodium instead of copper cations. And this needs, I would say, some clarification how the structure will change. And this is also a little bit linked to your chapter 4, where you talk about these geo-inspired materials and your thoughts that it could be an alternative regarding or new material for batteries. This chapter ends that you wrote, we demonstrated the electrochemical behavior of sodium copper sulfide either versus sodium or versus lithium to understand the principle of battery working. I did not find any lithium-bearing phases you studied in your thesis. So maybe I missed it, but also in your presentation, you were not mentioning this. So how you can compare the sodium and the lithium if you not really have studied the lithium. And then the last comment I do have, it's like a general thought, and it's again more like a fundamental question regarding nature, regarding the fumaroles. And could you please tell us a little bit more, something like the most and the least common? So those cations which are more concentrated and those which are not really concentrated in volcanic fumaroles. And also to provide a little bit information where those fumarolic gases are coming from. And therefore, which you would expect on other cations that might be incorporated in those sulfide minerals. So those were my thoughts, which I put down also in writing. And in general, I really have to say that you were not able to only synthesize new compounds. You also, which is really good, you fully characterized the crystal structures of all those new compounds you synthesized, and you included the review of natural sulfides. You derived geochemical, magnetic, thermal, and optical properties. And therefore, this is beyond doubt that the thesis is really a solid piece of work, I have to say, and a high level for a PhD student. And therefore, to conclude, I also agree that Mrs. Nekrasova should be granted the award of candidates of geological and mineralogical sciences at St. Petersburg State University, scientific speciality 164, mineralogy, crystallography, geochemistry, geochemical methods of mineral exploration. Thank you.
Thank you, Astrid.
Thank you, Astrid.
First one about in-depth information regarding finally used method for their applicability in nature environments. Synthesis in vacuum was used to the process of transfer from the gas phase, which mimic natural minerals formation from the gas phase. We have no possibility to carry out such experiment with open tube in oxygen atmosphere. However, we hope to do it in the future. The sealed tube without vacuum but with oxygen would explode. However, as I noticed in my work, there was no chemical vapor transport in the studied system, but the vacuum made it possible to create conditions suitable for synthesis and growth for the single crystals. Next one question about chapter 5, sodium intercorruption with copper. Sorry, it was a misunderstanding. This is question of ethylenite and not glycinite phases. Glycinite does not contain alkali metals, so it's just misunderstood. Next one about sorry. Now it's better hear me, yes?
Yeah.
So, okay. May I just interrupt, because I thought that you wrote something somewhere that sodium can be is an impurity. So where is it actually in the structure?
No, I could not say like this. It's misunderstanding. No, we could not incorporate for alkali size to the M size. It's because it's not. It's different position. Next question regarding electrochemistry about interaction of the lithium and sodium. The electrochemical behavior of the serotinoid type was investigated in lithium and sodium half cells. Its galvanic cells, which half cell consist in electrode, cathode, and anode, and electrolyte. The cathode, in our case, is serotinoid type material, and the anode is sodium metal or lithium metal. There is no lithium in the material, you're right, but we try to introduce lithium into the structure. In theory, if lithium is an anode and electrolyte or on lithium, we charge oxidize copper to 3+, one sodium goes away, so is neutrality. Then discharge, reduce copper back to 2+, so we don't have sodium anymore, but you need neutrality. Thus, we try to incorporate lithium into its place, which is taken from the lithium anode via lithium electrolyte. So it's how it works. And then about more in-depth information to provide overview about most common cations in volcanic fumaroles. The most often found fumaroles on volcanic Tolbachik are such elements like sulfur, oxygen, chlorine, fluorine, sodium, potassium, magnesium, aluminium, ferrum. However, it should be noted that the Tolbachik volcano mineralization is unique, and there are a lot of such elements as lead, arsenicum, bismuth, copper, zinc, selenium, thallium, and etc. The least common rare it's rare earths and actinides. The diversity of this mineralization is due to the unique of for nature objects combination of physical and physical-chemical condition and mechanism of its formation. There are high temperatures, atmospheric pressure, very high oxygen fugacity, gas transport of most components, direct deposition of many high temperatures minerals from these volcanic gases, which have specific geochemistry, including strong environment of alkali and ore elements, and interactions with basalt scoria. So, I'm finished answering for your question, I think.
Yes.
Thank you. Astrid, are you satisfied with the question?
Yes, I am satisfied. Thank you very much.
Okay. Now, Galusky and Gennady Vasilievich, I don't know, would you like to speak in Russian or in English? The floor is yours. I'll speak in Russian if you don't mind. Can you hear me? Yes, please. Thank you. I'm only sorry that the applicant had to use two languages to write such a lengthy paper to communicate her research. I think the main problem here relates to the style. They are connected with the fact that works based on publications in very good journals, there should be some kind of a guide and articles are attached. That's how I approached to my work to write in the review. First, I opened the Russian text, and indeed it contained so many digressions. The Glycinid was opened in September. I liked that most, but these are all minor errors because later I took the articles. I did not read the text itself. I carefully read the articles, and the articles are, of course, were reviewed by professional reviewers on a very high level, working in this field. So to me, I cannot find or add anything, any critical remarks. Of course, it was a difficult task for me. That's why I'd like to emphasize that my approach was somewhat formal. The applicant published 6 articles and 3 additional articles she published after so she submitted her thesis for review. The articles were published in highly ranked journals, index of over 5 in some cases. So I will be quite brief. I liked everything. So for formal requirements, I think the work complies to the above the average level if we talk about the European level of candidates' thesis. So I regret the time she was spent. Of course, I have no critical remarks in essence, and not to waste your time, I'll just read the conclusion, that final part, that the thesis by Nekrasova, Diana Olegova, on the theme New Sulfate Inorganic Compounds with Transition Metals, Crystal Chemistry and Physical Properties corresponds to the basic requirements set by the order dated the 19th of November 2021 number on awarding academic degrees at St. Petersburg University. And the applicant, Nekrasova Diana, deserves awarding the degree of Candidate of Sciences, specialty 164, Mineralogy, Crystallography. And Articles 9 and 11 of the above-mentioned order has not been violated. And once again, let me emphasize that I had the opportunity to attend quite a number of defense procedures, and I would say that this work is good, this thesis is good. Exceeds the average level by far, and all I want to do is wish the applicant further success in the same field. But I'd like to make one comment here. It seems to me that very often we try in laboratories to replicate natural processes, which is not possible in most cases. And here, the novelty of this work is not because the applicant tried to reproduce a natural process, but she obtained products similar to the natural processes, and I think that is important. Thank you. Thank you, Evgeny Vadimovich. The floor is yours, please. Thank you very much. I think we can continue, right? So, well, dear colleagues, my review is positive, but I've got some critical remarks which are very similar to those made by my colleagues earlier, but I would still like to read them because I think it will be useful for to the applicant. So the first comment about the missing introduction. I'd like to say that so we don't have a requirement to have an introduction, but I think it would be good to introduce this requirement formally, because the thesis, so here I don't quite agree with Evgeny Vadimovich. So a thesis, of course, can in totality, but you need 3 times more articles. Please remember that. And here's what I wanted to say. So the thesis is a result of work conducted over a period of time, and it's an overview of your own works and of the works of your predecessors. And that's why the literature overview and the introduction are needed to demonstrate that the author understands what he's writing about. So it's not about a collection of technical articles. It's how well the author understands the subject of this study. And since I happen to know that in France, the school of inorganic chemistry and crystallography is very strong. It originated back in 1970s, and I've read many theses presented in France, written in France, and I've never came across a single one without an introduction, a literature overview. So I don't think that you can say as an excuse. So that's first thing. And a suggestion, recommendation to the author, maybe she should pay a little bit more attention. The second point is connected with the first one. Having so much material, the reference list of is less than 70 sources is too short. So there's a wide class of compounds, transition metal compounds, and so this list is sufficient for a single article, but not for an overview of which a candidate's thesis should be that we are discussing. And that, in my opinion, is happened because there is no real introduction, which is so where state of the art of issue is. So if you try to write an article without an introduction in any of your journals, they won't accept it. If you apply for a grant without an introduction, your application will never be accepted. So please, it's an important part of research work. So please consider that in the future. So hopefully the applicant will remember this in the future. My third comment was already mentioned by my colleague. I don't understand why the use of natural minerals as prototypes is called novelty here. This is such a well-known thing, which has been known maybe for 50 years, since 1970s. So the structure of the skit. All these things. These are prototypes of huge classes or in material science. I don't know why you call it novelty. This novelty, and at that I was impressed that you never said that you've synthesized almost 20 synthetic compounds and described not only their structure but also their properties and electrochemical structure, because that is your main contribution into mineralogy and material science. And so here I actually wanted to say something good about the author. Such works are actually very good and useful, and despite these obvious errors and drawbacks, the work is certainly very good. As for the publications, of course, are and the references will be made. Not only references will be made not only by chemists but also by. So the six. I said that. So that certainly excuses the missing introduction, explains but doesn't excuse it. But despite these drawbacks, of course, as the chairman, I have no doubt that your thesis is a complete, genuine. So the thesis by Nekrasova Diana Olegovna on new sulfate inorganic with transition metals, crystal chemistry and physical properties complies with the main regulations established by the order dated the 1st of September 2016, number 6821/1, on awarding academic degrees at St. Petersburg University. And the degree applicant, Nekrasova Diana Olegovna, deserves awarding the degree of Candidate of Geology and Mineralogy, specialty 164, Mineralogy and Crystallography. Geochemistry, geochemical methods of mineral prospecting. Articles 9 and 11 of the above-mentioned order has not been violated. So, I congratulate you. We will vote shortly. You don't have to answer my comments because they are quite similar to the questions asked by my colleagues. Thank you, Sergei Nikolaevich. Thank you very much. Since the applicant answered all the questions individually, so we don't so if colleagues have any still have any questions, it's okay to ask. So is everybody satisfied? Yes, everybody is. Everybody's satisfied with Diana Olegovna's answers. So dear colleagues present, attending, do you have any questions? If you have any questions, is anyone willing to speak or ask a question? Nobody. I think we've already given the applicant a fairly hard time already. Okay. Then, the next item of our procedure, these are speeches of the thesis supervisors. Dear Oleg Yohannesovich, please tell us about the applicant and her work and your impressions of the applicant. So I will have to take a technical break, number one.
I'm sorry, Marie, just, can you... Так, у меня это просьба, Мари, пожалуйста, можете, зачитывать не нужно целиком отзыв Оливьера Хернандеса, но основные положения того, что он написал, и общее впечатление о работе. Пожалуйста, можете передать? Hello? Ага. Прекрасно. Oh, thank you. Спасибо.
Hello to everybody. So, I am Olivier Amandel, Associate Professor at University of Rennes 1 in France. I will be very short because the connection is not so good.
I'm sorry. One minute. Уважаемые коллеги, мы заканчиваем технический перерыв и теперь слушаем отзыв доктора Оливьера Хернандеса из нашего французского коллеги. Пожалуйста, продолжайте.
Please continue.
Yes. So, I produced a report
написал
and everybody could
отзыв, который все могут прочитать.
My conclusion is that
И мое заключение
I give without hesitation
следующее. Мое мнение, безусловно, является положительным.
Of Mrs. Nekrasova.
Госпожа Некрасова.
I mentioned few remarks on the manuscript.
Я сделал несколько замечаний по поводу самой рукописи.
That are detailed in my report, and the candidate can use it to improve the manuscript.
Я надеюсь, можно использовать для того, чтобы улучшить качество.
Maybe,
возможно,
as it's usual in France,
как во Франции принято,
ask very few scientific questions to Mrs. Nekrasova. The first one is linked with page 72. You wrote that copper 2 plus admixture controls the formation of ethelminate and glycinate, and I am interested to know more about this phenomenon. Second question, you mentioned the Eldane gap versus the Magnon gap in chapter 6, page 113, and also the magnetic anisotropy. So could you comment a little bit on why you refute the Haldane physics? And second, what is the role, to your opinion, you gave to the magnetic anisotropy?
Спасибо, Diana.
Thank you. Can you hear me?
Thank you, Olivier Hernandez. First question was related to the. Could you remind?
Could you remind what was your first question?
About in chapter 5.
По пятой главе.
Page 72.
На 72 странице.
Why in glycinite the copper controls this crystal structure? Yeah, it could be because without copper we could not obtain this full chain. Also, in separate our goals, because of the zinc is not so interesting of the point of the magnetic properties. Of course, our goal was to obtain copper-related compounds without zinc. And when we tried to do this kind of investigation, synthesis, we did not achieve results. So it means without zinc, this crystal structure could be exist. It's a very interesting point, and we give this result that without zinc it's not possible. And it's why we conclude that zinc control this crystal structure.
Okay, so about question on magnetism, Haldane physics on magnetic anisotropy, could you comment, please?
Yeah, it's more related to the end of my work. I will go further.
It's page 113. Chapter 6.
Yeah, because I don't have instead of me my thesis, I have just only my presentation. And here, yeah, we conclude that our materials don't go to Haldane chain. It's because they thought if we will go to see this heat capacity anomaly for the potassium, they did not show it. But in our experiment, we have it, like here in the. In this case, for potassium, you can see here. And it means that we have ordering and also this kind of material more related to square lattice model. The connections between these atoms through clusters is also existing. It's not linear, it's like square lattice as mentioned on this slide. Everything was confirmed by DFT calculations.
Okay. So, Mrs. Nekrasova, I would like to once again give to you all my congratulations. Thank you very much.
Okay, thank you.
Спасибо большое. У нас...
Thank you very much. We have another French colleague, Professor Olivier Mendré. He'd like to give his opinion and maybe provide some recommendations.
Yes, thank you. I will be very short. Well, the context, there is a lot of discussion about the acknowledgement and things like that, but the context of this thesis is, of course, a collaboration, a rich collaboration that we already started with Oleg and in the past with Sergei Krivovichev and Oleg Sidra a long time ago. This time ago, it was a very rich experience, and this chemistry of sulfate was very important. So Diana, it was a kind of very, you shared your time in between Russia and France. It was not easy for you, due also to your family life that you had all together, that you have to combine with this research experience. I was very happy and satisfied of your work. I think Mary will give a short comment on this also. I just have few comments. It's not, I don't know if it's a tradition that, can you hear me or not? I'm talking alone?
No, we can hear you.
Can you hear me?
We can hear you. Yes. Yes,
So
we can hear you. Yes, please continue.
I can continue, okay. You expect me to be translated, maybe, no?
Russian part.
It is translated. It is translated.
Okay. So I have to speak slower, maybe. No, it's not a general habit, maybe, in Russia that the supervisor asks a question. But I have one or two just comments, and I would like your opinion, very general opinion, Diana. For instance, there was a lot of comments on electrochemistry. Now, before that, I would like to that you recall to the people maybe why you selected rather large alkali like rubidium and cesium rather than small ones like lithium and sodium. Could you comment about this?
Yes, of course I could comment. It's because of already a lot of investigation was done for lithium and sodium because they are light. They're very common uses for electrochemists. For example, there are a lot of work by Taras Kohn was done and their PhD students. And also my goal to obtain new materials. And when I work in this system, also with lithium ones, I found that we already has a lot of crystal structure. And more want to say that lithium, it's not go to this one crystal structure type. They are more separate, like lithium, sodium, and cesium is different absolutely, while potassium and rubidium, they are more related. And because of a lot of structure investigation was already done, we skipped this fact and go to the more maybe not so interesting of the viewpoint of the electrochemistry, rubidium and cesium, because they are very heavy and of course they could not be interesting. But for question of the science, fundamental science also should be complete by our work.
Yeah, I agree with you, but I think that we could go further a little bit. I mean, to answer one question, what comments that was given by one of your colleague, reviewer, about the fact that you incorporate lithium in the sodium phase. Do you think there is any possibilities to incorporate lithium or sodium instead of rubidium or cesium in this kind of very interesting architectures where you have got either channels, either layers? Do you think that somebody could happen electrochemically?
I think it's a good question because it will be very big distances due to the ionic radius of rubidium and cesium, much more bigger compared to the lithium and sodium, of course. And if we will put this except, it's too much. I think it's not possible. Crystal structure does not exist in this case. It's too big distances.
I mean, I think that we could electrochemically, there is new architectures that exist in which maybe we could go further and try to deintercalate this large rubidium cesium, stabilize metastable compounds, and then incorporate lithium or sodium. That's something that can happen sometimes. So I think that at least it's just the first step of. There is a lot of things to do further. I just took this example, but also with the compound with copper and the magnetism, there is a lot of new things to do. It's not complete thesis. It opens a lot of opportunities. That's all. It was just a comment to give you the fact that it opens a lot of horizon.
Yeah, it's true.
Anyway, I have to thank you for your presentation and for all the work you did. I think that I give back my words, maybe to the president, and I think that Mary, I give you.
Okay, thank you, Olivia. Thank you very much.
Спасибо. У меня вопрос к французским коллегам.
Thank you. I have a question to. Do you have other colleagues from France who wanted to say or comment? Say something and make comments. Maybe not. Okay. Thank you. No. So we are done with answering questions. Let's proceed to the supervisor, Oleg Johannesovich. Could you please tell us a couple of words about the applicant? Please. Thank you very much for the opportunity to talk. Since I have to tell about the applicant and introduce her, like how long I've known her, I've known Diana for a long time, maybe 10 years. She wrote her bachelor's thesis, her master's thesis, and all the time she was a student of mine. And I think that Diana is a unique example. She could have written and she could have presented in lead carbonates. That's what she has done as a bachelor and master's student. She published her own 6 articles. She co-authored very interesting minerals. Yes, and then Diana's main method is monocrystal analysis. She mastered it on using such complex material. So that was one of the most complex cases. In my case, is you have to choose twins. There will be, and Diana gaining all that experience, getting that all that experience as bachelor and master student. She then, with her usual ease, she agreed to take up a completely new theme, which is these are sulfates of base and transition metals, and she obtained a number of very interesting results. Indeed, some main families of such sulfates, bases and transition serentinites and a number of other compounds. She either started these families or made significant contributions to these families. The development of crystal chemistry and crystallography and all this synthetic work, which Diana has done that in her first year already. So if she continued, I don't know how much time, but then she gave birth. And because of that, maybe she couldn't spend as much time, but she managed to complete her work. She prepared and she wrote a number of good articles. Of course, she should have been more careful and paid more attention to the structure of the thesis and to the presentation. That's her work, that's Diana's work. And I hope she will certainly consider all these valuable comments in the future, no matter where she works, because that's very important to present your results and present your successes, no matter what they are. But the presentation really matters, and you have to be very careful doing this. Diana today has been working in a different field, different from crystallography and chemistry. When I saw her last week after a long break, so she's thinking about taking up she's going to look for a job. I don't know where she'll find such a job in these hard times, And speaking of her work, her thesis was prepared under two supervisors, Marie Calmont Elementary, and me as on the behalf of St. Petersburg University. That's mainly that's a bit unusual, but that's standard practice in France, where a doctoral student has 2 or 3 thesis supervisors. That's a very standard practice. That's a very unique case, and such. So Diana will get a diploma from the University of Lille, and of our according to the results of her work. And last time this happened was Vadim Kavrugin. This was like 10 years ago. And of course, I have to say that from the point of science, such cooperation is very fruitful. Turned out to be very fruitful. Let me emphasize in conclusion that such versatile attitude that Diana has published over 20 articles, and all these all published in the first or second quarter. And in Diana's case, this co-authorship is not because she was added because she took some photos or brought some samples. This happens, of course, but this is not Diana's case. She is a real co-author of all these 20 articles, which indeed evidences her great contribution in obtaining a number of interesting results. And in conclusion, Diana spent half of her time in Lille and half of her time in St. Petersburg. She has excellent skills. She's an excellent professional in solid-state chemistry and in crystallography. And of course, she's an excellent expert in the field, which characterizes the main characteristic. There's crystal structure analysis. Here, Diana can solve very difficult tasks. So I have no doubt that Diana deserves awarding the degree. Thank you, Candidate of Sciences. Thank you. Thank you, Oleg Yohannesovich. And now, let me ask Marie Calmont, French supervisor, thesis supervisor, please tell us about the applicant.
Yes, thank you very much for giving me the opportunity to discuss about Diana. So, as remembered by Oleg and by Olivier before, so we are happy about this collaboration with the University of St. Petersburg, started almost 10 years ago with the thesis of Vadim Kovrugin. Also in the lab, we hosted a few years ago Anastasia Zadoya, that I can see in the audience, that received a PhD degree of the University of Lille. And so now it's our third student that will hopefully receive the degree today. And Diana came with strong skills on crystallography. And in the University of Lille, she did a lot about synthesis and also about physical property measurements. She learned a lot about magnetism and electrochemistry, especially when she went to the University of Amiens to do some measurements. So I think through these 3 years, she got a lot of skills about 7 fields on inorganic chemistry. And I think she's now well-grounded to study complex cases. And Diana, we were really happy to host you in the lab. And we want to wish you all the best for your future, and also all the best for our collaboration with Oleg, our colleagues of the University of St. Petersburg. Thank you very much.
Thank you, Marie.
Thank you, Marie. Dear colleagues, I think we've covered everything, but I still have to ask you if you have any outstanding questions regarding the thesis, So you have this last opportunity to speak. So nobody wants to speak. At that, the discussion part is closed, and let us proceed to the next stage of our session. Before we vote, I have to ask the council members and the applicant the following question: if council members have any remarks or questions regarding the procedure of this session, and have you experienced any issues with remote access? And I have to get formal answers from all the council members. Elena, no, I have not experienced any problems. Alexey Ilyich, no. Evgeny Vasilyevich, Vadimovich, okay. No. Astrid,
No,
have you had?
everything fine.
So,
Questions?
and
То есть получается, что все удовлетворены.
they are satisfied with the discussion, the presentation, and the answers of the applicant. So let us proceed to voting. We have two options. So the first option, so dear colleagues, if you want to discuss something with the sound switched off, if we need some confidential discussion, if we need that. And the second option, if we don't need such a discussion, we can just proceed. I understand, since all the opinions were positive except for some minor comments, so perhaps we will not have this private discussion. But then let us continue our session and let's proceed to voting. At that, each council member has to give his or her opinion individually and independently. It's 4:57 Moscow time, 4 p.m. Can we all hear each other? I understand yes. I put the question of awarding the question to Nekrasova Diana Olegovna, the degree of Doctor of Geology and Mineralogy, specialty 164, Mineralogy, Crystallography, Geochemistry and Geochemical methods of mineral exploration, to the open individual vote. Let me emphasize that by voting for, each council member agrees that Article 11 of the order has not been violated. I have to quote Article 11. In a thesis, the candidate for the degree shall be obliged to refer to the author and or the source of foreign materials or individual results when using in the thesis the results of scientific works performed by the applicant personally and or in co-authorship. The applicant shall be obliged to mention this circumstance in the thesis. And let me remind you that a decision of the Dissertation Council on awarding the degree shall be considered positive if over a half, but not less than 3 members of the Council voted for it, according to Article 23 of the order. We have 5 Council members, so we need 3 positive votes. So let me start interviewing. Alexey Ilyich Brusnitsyn, your opinion, please. I am for awarding the degree. Articles 9 and 11 have not been violated. Council member Elena Belagub, I am for awarding the degree. The articles have not been violated. Council member Galuskin Evgeny Vadimovich, your opinion, please. Articles 9 and 11 have not been violated. I am for awarding the degree. Thank you. Astrid Holzheid, your opinion, please.
Article 9 and 11 has not been validated, and I agree.
Спасибо большое, коллеги.
Thank you very much. And as the chairman, Britain, Sergei Nikolaevich, my opinion is that, of course, Articles 9 and 11 have not been violated, and the applicant deserves awarding the degree. Now, I have to count the votes and announce the results. Thus, dear colleagues and guests, let me inform you that out of 5 council members, 5 voted for, nobody abstained, and nobody voted against. Thus, the decision to award to Nekrasova Diana Olegovna the degree of Candidate of Geology and Mineralogy, specialty 164, Mineralogy, Crystallography, Geochemistry, and Geochemical methods of minerals prospecting, has been made. Closing remarks of the applicant, please. Thank you very much. Since I'll use my native language, since there is a translator. First of all, I'd like to thank the people who, throughout my entire study period, provided me advice, personal advice, Evgeny Nazarchuk and Vadim Kovrugin. Also, I'd like to thank my friend Anastasia, Artyom Borisov, and Jennifer, my foreign friend. Hopefully, you guys can hear me now. And of course, I'd like to thank my family, my husband, Roman. As you know, we have a baby, and a lot of time he spent with the baby. So thank you very much, everybody. Congratulations. We congratulate you sincerely. And the last official session is closed officially. Thank you for your participation. So please stop the live broadcast.